Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Aqil Najmi bin Muhammad Zahani, and today I will be presenting about Archimedes principle for my lab 1 fluid statics. So in this video later we will talk about the introduction to the experiment, objective and methodology, which is procedure, setup of the experiment, result and discussion, and also conclusion. Archimedes' principle states that the upward buoyant force that is exerted on a body immersed in a fluid, whether fully or partially, is equal to the weight of the fluid that body displaces. Static fluid equilibrium condition explain how the displaced fluid was in equilibrium with the surrounding fluid before being displaced. So the buoyant force on the displaced fluid was equal to its weight, and thus an equal buoyant force was exerted on a solid body. So this Archimedes principle is applied to all state of fluids, gas or liquid, where the object is fully or partially submerged. So in this experiment, we are going to demonstrate buoyancy is different for different liquids. This experiment objective is to investigate the relationship between the buoyant force of an object and the weight of the liquid displaced. Also, this experiment is to evaluate the effect of the different density of fluid to the buoyant force of an object. So move on to the methodology. The first step is to hang a spring balance to the arm of the retort stance, tie the metal bolt with a string and hang on to the spring balance. And then we record the spring balance reading, which is going to be our first W1. And then fill an overflow can with water until the water level touches the spot of the overflow can. Place it under the spring balance. And then keep a beaker. And then we record the beaker's weight, which is going to be our P1. And then we move the arm of the retort stand with the metal bolt and still tied to it, slowly downwards. As soon as the metal bolt is suspended in water, the weight on the spring balance scale is recorded, which is our W2. And then collect the water that is overflown in the beaker, and then we weight the beaker with the water, and then that's going to be our P2. And then we calculate the weight of displaced water, P2 minus P1, and then prepare salty water by taking 500 ml beaker, adding 300 ml water in it and dissolve the salt, and then get the saturation. And then we're going to repeat the same step from step 1 to step 9 with the same metal bolt with salty water. Okay, so this is the visual of the experiment that I said before. This is the list of the apparatus. Then you can see the metal bolt is attached to the spring balance by the string, and then the experiment will be go on like that. So here are our results for the experiment. In the first table, you can see that we got the apparent loss in weight of solid body in tap water, and for the table 2, we changed the salty water, changed the tap water into the salty water, and then we got the results of the weight displaced water, P2 minus P1. Okay, so what do we got from our experiment? What we can discuss is the first one is weight of water displaced is the same with the buoyant force. And then due to the buoyant force, weight is reduced when an object is fully immersed in the water. We can see why the water is displaced by the metal pendulum when it is inserted in the water. And then buoyant force is acting on the object depends on its density of the fluid and volume of fluid displaced by a body. And lastly, we can see that when the metal bolt is immersed, water displaced is more when we use the salty water. So what can we conclude from our experiment? The first one is the greater the density of a liquid, the greater the buoyant force. We can see that the buoyant force is equal to the weight of displaced water, so that the Archimedes principle is approved, right? That's all from me. Thank you very much.